Hi everyone, are you able to hear me clearly and see my screen clearly? All right. All right. Okay. So, all right. So far we have covered quite a few things. We talked about big data basics. Then we talked about storing data. Then we talked about doing the batch processing. I mean, we talked about execution using yarn. And we also talked about MapReduce, then we talked about Hive and Pig, and then we talked about Scoop, Flume, Uzi, and NoSQL HBase. All right, so today we are going to talk about Scala. Why are we going to talk about Scala? All right, so 9 October, let me save the notes. All right. All right. Before we jump into Scala or Spark, do you have any questions, or do you want to suggest that we should cover something else? Rebecca's question is, when is the last day of the course? So I think there'll be probably two or three more classes. I think three more classes than this. Okay. So I'm hoping that uh, probably 3-4 classes more, and that should be good. All right, Rebecca. Okay, so most likely 2 more weekends, and that's it. Any other question at this point? Okay, so the next weekend and next to next weekend. So that means what will be that? 14 plus 9 is 23rd. Most likely 23rd of this month. All right. Any other questions at this point? No questions? Yes. So I'll make sure that you all have the access to the lab. Okay. And access will be 15 days from the last day. Okay. 15 days after the last date. That's the approximate access for the lab. While the content will be available to you forever. Yes. The videos and everything. Okay. So when I say lifelong, it means either the life of the no big data as well as mine. All right. So, okay. Shashi's question is, are there any videos for installation in local? The general way is that you can install using the virtual machine. Okay. All right. Bernie is saying that yes, 90 days. So, okay, that's correct. That's correct. Thank you, Bernie, for reminding me that. Okay. So, yeah. So, okay. So my point was that in case it is expiring for some reason, for some people, those who actually enrolled for my class 1 month ago, then for them it might be beyond 90 days. So for them it'll be extra 15 days. All right. So whichever comes last, either the 90 days or 15 days from the last day. Okay. All right. So Shashi, we have a video, or not video, instructions on installing on the local machine using the, okay, using the, here you can see the, this one, these two should be good. Okay, good. Now moving on. All right. So today I want to first discuss one thing called the project that we haven't discussed yet. Okay. Um, okay. All right. So there will be 10, 11, 12, 13. Yes. Okay, just a second. All right. Okay, I think you have access to the other course, right? This one. Okay. So I'm thinking that even though it's the current course is about Spark, I would love to give you a small project here. Okay. And we'll also update the current curriculum with that. So though it wasn't planned, but I would love to give you that project, and that'll be quite useful for you. Okay. So you can take a look at this project. All right. Okay. So I have also put it in the chat so you can take a look. And yes. So the idea behind this project is to check whether we have learned something or not so far. And here the problem statement is to do the sentiment analysis based on the tweets. Okay, is it recorded? Yes, it's being recorded. All right, so the objective of this particular project, which you have to do, is do the sentiment analysis based on the tweets downloaded from Twitter. Okay, so here I have provided one of the very basic strategy. It's a very primitive strategy for sentiment analysis of the movie Iron Man using Hive. It is up to you whether you choose exactly the same steps or you choose a different strategy altogether. All I would want is that you give me the end result, you either the screenshots or the project report, any of that, you provide me, and that'll be good. Okay, so you have to submit a kind of maybe the screenshot, the complete report, whatever way you can convey that you have finished the project. Okay, and I can reproduce the same thing. All right, you can do, there are various kinds of deviations possible for this project. For example, you can use pig or spark instead of hive, or use a completely different algorithm to compute the sentiment based on NLP. Okay, right now we are going to use very primitive strategy to compute the sentiment of each tweet. Okay, what does it mean by sentiment? Whether a tweet is negative or positive, that computation we are going to do. And how are we going to do in this primitive strategy which I'm providing is by breaking down the sentence into words, matching each word against a dictionary, and from the dictionary we will it's a sentiment dictionary whereby we have positive or negative connotation against every word. Okay, then we sum up all the sentiment, and then all the sentiments of each, the polarity, the negative or positive word, we sum it up and compute the sentiment of the whole tweet. All right, so all right, so this is one of the projects. There'll be one more project, one or two more projects on Spark that you will have to finish. Okay, all right, now these are the various variations possible. You could take a look at this particular URL for more variations on the sentiment analysis. Okay, so one is that you log in into Hue, take a look at this folder that contains data. You can make a copy of this one. Okay, you can make a copy of this one, and then you basically create your own database inside SQL. The query is located at this place. Okay, query to compute the sentiment of each tweet is located here. At the end of execution of this query, inside your database, you will have the tweets BI table. Okay, that's the end result of running this query. And this tweets BI will have the sentiment against each tweet. All right, so let's take a look first at the data. Okay, you can see there are three folders. First is dictionary, second is time zone map, and third is tweets raw. And all the three things are a folder. Okay, inside dictionary, you can see that it's a tab separated file containing word. Here you can see it's an abandoned word. Abandoned is the word. It's a negative word. You can see negative. Abandoned is again a negative word. Okay, so you can see negative, negative, and so on. And if you see above is a positive word. Okay, above is a positive word. Then around is a positive word. Absentee is a negative word. All right. While actually is a neutral word. All right. So we are going to use this to compute the sentiment. Now take a look at this particular query. Okay. So here, I mean, all of these things are mentioned here. So go from top to bottom. All right. So the first thing is you basically copy this JSON jar into your home folder. Okay. So I'm jumping a little bit faster, going back and trying to be a little slower. So first thing we do is we are trying to take a look at the data provided in the project document. Okay. In this document, the first one is the dictionary. Second one is the time zone map. In the time zone map, we have a correlation between the time zone and the country. Okay. So we will convert the tweets. There's a time zone associated with each tweet. So we can convert, we can, estimate the name of the country based on the time zone. Okay, so that's a quicker way of easier way of estimating the time zone, because Twitter does not provide you exact country name. Therefore, you will have to use the time zone. Like for example, on our websites, we generally use either the time zone or the IP address. Here, IP address is not available for country. Therefore, we are going to use time zone. The only downside of it is that uh, there are some uh, countries whose time zones are same, but luckily that wouldn't be the case here. All right, good. So we have got uh, three data sets so far, two data sets so far. One is dictionary time zone. Third one is the tweets. These tweets are compressed in the ZZ format. Okay, and this is every line is a JSON in these files. Every line is a JSON. Okay, so you can see that this is one JSON object, then there is another JSON object, and these JSON objects are separated by new line. Okay, so who all are comfortable with JSON, or you want me to explain? Have I explained earlier what is JSON? All right. Okay. So everybody else other than Michelle and Christine is comfortable, or you are just not saying things? All right. So please be active, and I would love to, you know, I'd love to have a great feedback. Okay. Okay. So JSON is a format similar to XML or some other formats. You have various kinds of formats like comma separated values, tab separated values, and so on. Comma separated values and tab separated values are very simple. We write something like A, comma B, comma C, and then new line, and then A1, comma B1, B1, comma C1. Okay, so similar is the case of tab. Okay, is the font okay now? All right, so in case of tab separated, we have A, tab B, tab C. So when we store data in a file, how are we going to structure it? When I say, uh, let's say there is a person, say Sabanand. Sabanand is a student of big data class, and Sabanand is also an engineer from the background. Okay, and his interests are such and such. So to represent that this kind of data, we would need some kind of format, either tabular format or a complex format such as object formats. Okay, so we could also, let's say, put similar data in XML. Okay, let's say we say name is, okay, name, we'll say person, and name is Sabanand. Okay, and like this. And we could also say the education is something, and okay, we could say engineer and education ended. And then we could say, let's say location, and inside location we could say, okay, office. All right, so this was kind of XML format. You can see that it has taken me a long time to type, and that's exactly the problem with XML. XML formats are quite verbose. We have to write person twice, you can see name also twice, and so on. as compared to the CSV formats. Okay, so if we have to do the same thing, we would in JSON we would say name Saba like this, and we'll also say education engineering, and we could say location, and inside location we have further you can see that you could see that inside location we are saying office, okay, is this, and residence could be something else. All right, so you can see that we can form the object in this way. All right, Michelle and Christine, everybody clear about JSON? So in JSON, we could create arrays. Okay, we could say 1 comma. Okay, we could say, what do you say? Array is okay. We could say education degrees. All right, and in this, or we could say things like movies. Okay, movie likes. We could say he likes Matrix, he likes some more things. All right. So this way we can define an array. All right. And so we could also say number, say like this. Okay. So this is JSON format. Let's take a look at the JSON format we are talking right now. And we have this in a single line. This whole object is in a single line. You can see that if I copy paste it here, it is basically single line. If I remove soft wrap, the whole thing is in a single line. Let me try to format it so that it makes sense to all of us. Okay, and how do you do that? JSON. So Mrtyunjay's question is this used in Twitter/Facebook? Actually, the whole world uses it. The browser understands JSON very well. So we are using this website called JSON Formatter to kind of clean up our object. Now it looks very nice here. Okay, you can see that. So here it is showing our single tweet. Okay, it says the text is this. The text is this. It's by, okay, so you can see all the entities under it. This is the array notation, and there are no hashtags mentioned in the tweet, therefore no hashtags. Then you can see that, okay, so you can see all other things. This is the user, this is the person who has tweeted it, and he has said that the location is German. All right, location is German. All right. So you have seen, you can see all the details about a tweet. So every line is a JSON object, and we could actually use the same thing while we talk in Spark. Okay, so this is the data I have downloaded it using Flume. Okay, you could also use the same thing. The script of the Flume is available in the folder somewhere in the sentiment files, and you could take a look at that. Okay. All right. So that is a JSON format. Now, once you have taken a look at the data, now let's take a look at the SQL that we are going to use. First, we copy the jar file to the local. Even if you don't, you can actually do directly add jar hdfs :/ the location. Okay, and you don't need to copy it to local directory actually. Okay, then you can create an external table called tweets. Okay, and here we are saying that The row format is provided by this JSON survey. Okay, this jar file which we are providing contains the definition of this particular serializer, deserializer for this table. So we could essentially load data from any kind of format by using a third-party library. Okay, then we define a dictionary, then we define a time zone map on this particular folder, whatever is your location there, and then okay, and then okay, time zone map also you need to create, and then you clean up tweets, as in we only keep the records that we want. And once that is done, you first create a simple view of tweets, then you clean it up by joining it with the time zone, and then we start doing breaking the whole every tweet into one word at a time. And once that is done, you match it against a dictionary. You match it against dictionary, and then say things like this: when negative, then -1; when positive, then 1, and so on. Okay, so that's how we define the polarity, by joining the two tables. And once that is done, you sum up the polarity by after grouping it based on every tweet. And if the polarity is 0, okay, that means the polarity is 0, that means it's neutral. Otherwise, it's either positive and negative. So what we have done here is an interesting aspect. What we have done is we have every word is either denoted by 1, -1, or 0. Okay, and we are assuming a sentence, the polarity of sentence is equal to the sum of polarities of individual word. Okay, let's say I said not good, that means not is negative, good is positive. That means the sentence is, this is not good, the sentence is neutral. Okay, okay, so in the similar way, once we are done with this, we will have our clear table like this. All right, so you can see that. Okay, so use this and finish. I mean, once you have created this table, you can install one driver in Hortonworks in Excel. You can install the Hortonworks driver in Excel, and then configure it with your username and password inside Excel, so that your Excel, your Microsoft Excel, can directly plot the data. Okay, it is also possible to do it using the it is also possible to do this using the using some other tools. Like, there are quite a few tools for visual representation. If you do not like Microsoft Excel, or it doesn't work for you, make sure that while installing, you install 32-bit Excel driver if you are using 32-bit Microsoft Windows and Microsoft Excel. If you are using 64-bit Microsoft Excel, then you download the 64-bit one. Okay, so make sure that you use the correct one. Right, so that's pretty much, and you can take a look at this document. Right, so that was our project, and we talked about the JSON in between. All right. Good. Any questions at this point? Due date is, I would suggest that you do it before the next week. Okay, but you can do it at your own luxury. But I strongly recommend that you finish it before the next week. It wouldn't take too much time. All right. All right. Any other questions before we start? All right. So let's start with our Scala introduction. Okay. So we are going to discuss Spark later on. Okay. We would love to discuss Spark. Probably today we'll put the first step towards it. Okay. We'll try to do Hello World today, and we will do a lot of hands-on in Scala. Now, question is, why are we talking about Scala? What's wrong with other languages? So when we talk Spark, Spark is written in Scala. Therefore, the primary support in Spark is for Scala. Also, other than that, Scala being a new language and is actually good, therefore, the industry expects the people to know Scala. So if you go for interview, if you are, in if you are talking to people in the Spark in the industry, then people would generally prefer you to know Scala. Okay. Although so far I have taught using Python, and I find that using Python was less verbose, as in it took less amount of effort to write Python code, but Python code is a bit slow. So two reasons. One, Python code is a bit slow. And second is, Python is a secondary language with respect to Spark. So first, most of the libraries are available in Scala than in Python. Okay. For example, there is a component of Spark called GraphX. The GraphX is not still available in Python. Okay, so if you know Python, you won't be able to use GraphX. You will have to use Scala. Therefore, it becomes inevitable to learn Scala. Also, Scala is faster and Scala is well supported for distributed computing. All right. So Sabanan's question is, what functionality did the GraphX cover? GraphX is for doing the graph-based processing on large scale. Okay, so uh, how many of you know what is PageRank? PageRank algorithm from Google? Nobody? All right. Okay, so why Google became Google was because their search results were far better than anybody else. Okay, it is as simple as that. Their search result were far more superior and far more correct than any of the other search engines, and that was the sole reason why Google became instantaneously successful. Okay, and why were those results great? Anybody? Why were Google's result better than any of the competitors? Why were they more relevant? Yes, their algorithm. The algorithm they used was PageRank. That's correct, Kamal? Yes. So there, basically, the search results were computed based on the PageRank. Okay. And how does the PageRank work is something we will cover once we talk about GraphX after the after Spark course. We will take a day, say 10-15 minutes to demonstrate how to use GraphX and compute PageRank. What is PageRank? So pages are related to each other. Okay. Okay. So let's say there is a page of Microsoft. Okay, Microsoft, and okay, so Microsoft is linking to Hadoop. Okay, so on their Microsoft, if you visit, let's say Microsoft.com, if you see Hadoop.com on their page, so who is more important, Microsoft or Hadoop? You're visiting Microsoft.com's website and you see Hadoop, uh, a link to Hadoop page. Who is more important? Quickly. But Microsoft is basically linking to Hadoop. Yes. So Hadoop is more important. So I'm saying on my website, that that please look into Hive at apache.org. Okay, that means I'm telling that Hive is something you should go to. Okay, so similarly, so this is what PageRank is all about. If one page is giving the vote to another, let's say there is another company called Oracle, and they also have a link to Hadoop, and similarly, there is another company called SAP. They all are linking, having links to Hadoop. So the Hadoop's page rank is going up. All right. Hadoop's page rank is going up. Also, the page rank is recursively defined. What does it mean? If Microsoft has got bigger rank, then if they link to Hadoop, then Hadoop's page rank goes bigger. If there are very you know, so when these web pages are linking to each other, they are actually voting each other. That was the page rank algorithm all about. So more number of pages linked to you, your page rank goes higher. More number of pages, if pages which are linking to you are of high page rank, then your page rank goes even further higher. Okay, so that is the idea behind PageRank. So what Google did was Google downloaded all the websites from across the globe and prepared this kind of graph using HBase kind of model. You remember our HBase model where we had kept the data. So they downloaded all of these websites and kept it in the HDFS kind of file system, as well as they maintained the page graph in HBase. HBase, they have a similar database. Okay, and using a graph computation algorithm, say similar to MapReduce, they computed who is voting for who and whose page rank is how much. All right. So, and when you search for something, it will show the pages which are having higher page rank at the top, and the pages which are lower in the page rank at the bottom. All right. So that's how the whole page rank was designed. Is everybody clear about the page rank? All right. So this is a very clear algorithm whereby so they compute around 80% of their value to somebody who they are voting to. Okay. We will go into exact detail and I'll show you how to do. Okay. So this kind of algorithm, the PageRank algorithm, it needs to work on a huge relationship between these pages. These pages will form a huge graph. If let's say there is another company called, let's say, Documentum. Okay, I'm just whatever is coming to my mind, I'm just making that here. Let's say There's another company called XYZ. They're also linking to Oracle. So you can see that this way there will be some people who are linking to this, and there'll be lot. So this will kind of become a huge graph. And computing the page rank will become more and more complex. Okay, computing the page rank will become more and more complex every day, and it has to be recomputed every day. Okay, so basically this computation cannot be done in the memory. All the knowledge what we learned, if you are from computer science background, there would have been a graph chapter in the algorithm book, right? Where you learned all these, how to do trees and graphs and various kinds of data structure. The problem in that book was, in all of that learning, was that we learned everything in the memory. As in, we were told that we will load the whole thing into the memory. Although the same book called Corman, there is a book called Corman on data structure and algorithm, which is considered as the textbook. It has been updated. It has been updated with non-memory things now. Okay, so all right. So basically, whatever we have learned in computer science, everything was with the assumption that we'll be able to load it into the memory, whether hash table, whether tree, whether graph. We should be able to load it into the memory. And that's where the problem lies. And because this kind of graph cannot be loaded into the memory, therefore, new kind of tools were required to represent this humongous data as a graph. Okay, we were able to present a big humongous table in HBase, humongous file in HDFS, and if you have to present a humongous graph or do the algorithms on that humongous graph, we require either the graph-based database such as Giraffe, or we require these library called GraphX, which can operate on the graph kind of data on a huge scale. All right, so that's GraphX. We will talk about it. So we'll just run through one example each, so that we are all comfortable with the hands-on. Right. So the reason why we are learning Scala is, one, it's fast. Second, it is well supported in Spark. Okay, the way, if you are doing Hadoop development, it would be better if you do it in Java. If specifically if you are customizing Hadoop, if you are customizing Hadoop too much, then it's better to do it in Java than in any other language. But if you are using, say, MapReduce or any other thing that do not require Java per se. Okay, you do not require Java. You can do it in any language. All right. Okay, so yes, I will, Hank, I'm going to walk all of you through Scala. Okay, you all have to do Scala programming with me, so that we all are comfortable with it. So this introductory session is not supposed to be the comprehensive. It is supposed to just get you up and running. It is just supposed to give you the way to move forward. All right. Okay. So Scala is a modern Scala is a modern multi-paradigm programming language designed to express common programming pattern in a concise, elegant, and type-safe way. Okay, so here let's try to go through each word of it, because when these definitions are made, they are supposed to be succinct. They're supposed to be very precise. Okay, so Scala is actually a very decent language. it provides you a very simple syntax, similar to, say, Java kind of syntax, where you have curly brackets and round brackets. It is elegant and type safe. Type safe as in, you have to specifically, explicitly define type. Okay, unlike Python. All right. So it is statically typed. Scala is statically typed, and that is what makes it faster. There has been a continuous debate about Python versus Scala. In case of Python, it's not statistically typed. Statically typed, not statistically, statically typed. Okay. So what does it mean? So in Python, you could actually, let me remove this. Okay. Yeah. In Python, you could actually say x equals to 10. Okay. You don't have to define the data type of x. All right. Similarly, while defining functions or anything, we don't have to define the data types. This is Python. Okay. While in case of Scala, you have to define, say, where x equals 10. This is how you define the data type. Similarly, you could also define, okay, so Scala is statically typed. Okay, it provides the correctness before deployment, meaning you have to compile Scala, although Scala can be run without compiling. Okay, you can compile Scala before putting in production. That's an added advantage of statically typed languages. Okay, it's lightweight. The syntax is composable. It provides a lot of functionality, which makes it simpler to use in the production. Okay. Next is because it provides all those syntax which are very similar to the other data-centric language. It provides map and reduce out of the box. We will show you, and it is stable as well as innovative. Okay, so we will show you these examples, and then that will be more sensible. So the Scala's history is in 1990. Okay. So Hank's question is, it is kind of a scripting language. Actually, it is both. So while you will be using it with the, just like interpreted, okay. So you can use Scala like an interpreted language as well as compiled language. That is the beauty of Scala. Okay, so Martin Odersky, the creator of Java, made Java better via generics in Java-C compiler. Okay, decided to create even better Java. First experimental release was done in 2000. Okay, let me see why my voice is not good. There is facing some kind of voice. Okay, is it better, Dheer? Others are finding it fine. So I'm wondering what happened there. Okay, so in 2001, he created a better Java called Scala. All right, and then in 2005, he made it public, a newer version of Scala, which was written in Scala itself. And in 2011, it is started getting adopted in the corporate world. Okay, are you hearing the background noise still? Okay. All right. Again, a brief, a little bit more introduction about Scala, more theory. We'll jump into practical after this. So Scala source code gets compiled to Java bytecode, meaning for running Scala code, you don't need any other installation other than Java. Okay, if your machine supports Java, that means it can run the Scala code, okay, after it has been compiled. But if you have not compiled it, then you will need Scala interpreter, which will run it. Okay, so that's a very big advantage of Scala, that they did not need a new set of installations of Scala in the production environment. So when people say that, can we run our Scala program on the server? My general question is that, can you run Java there? If you can run Java there, then Scala can also run. Okay. So because in case of Java, when you compile it, your code gets converted into something called Java bytecode. And that Java bytecode is kind of run like an interpreter in the production environment. That is the case with Java. And okay, so same is with Scala. Scala code gets compiled into Java bytecode, which can run anywhere there is a Java virtual machine. Okay, this question is, that means compiled Scala code can be run from Java command. That's right. And Hank's question is, Python modules, pandas, scipy, scikit can be imported in Scala. So, okay. So Hank, here okay, it is Scala, not scalar. All right. Maybe I'm sounding little like scalar. Okay. And all right. So Python modules can be imported into Scala. Quick answer is no. But their main ones, what do you call them? Let's say pandas. Pandas is actually a library written in C. That library can be bound into Java and therefore can be bound into Scala. All right. Similar is the case with scikit-learn and scipy. All these libraries which you use in Python, they're actually written in C for the performance. Okay, you can actually bind all those libraries into Java. Java allows you to bind those libraries and use them inside Scala as well. All right. Jabirka's question is, can you tell what will get benefit? Can you tell what will get benefited if we have no data types? So if you don't have a data type, it becomes easier to code. Okay, it becomes easier to code, and the code looks far more cleaner. You don't have to type so much of data types, and you don't have to explain all kind of data type to a newbie, a new beginner. So those are the reasons why people prefer language without the data types. The other problem with the data types is casting and other runtime environment becomes very rigid. If you have statically typed language, in those cases, uh, the data type inference happens at the compile time in the statically typed language, and therefore, it becomes little rigid. It is not that dynamic, and because of this rigidness of the statically typed language, you need all kinds of mechanisms, say void pointer in C, reflections in Java, and so on. Okay. So question from Mrityunjay is, how char, int, or float is differentiated? Just like Java or C, Scala also have the similar differentiation. All right. Japrikas, was I able to answer your question? Okay. Further question is, as you said, Scala is more useful in distributed computing. Can you tell how that is? I'll explain to you as we go forward. Now, Shashi's question is, data types are dynamically assigned at runtime. So in case of Scala, data types are basically exactly the same way it is in Java. Okay, so data type verification happens at the compile time. At runtime, they are basically assigned. Okay, so most of the work happens at the compile time. All right, let's not get into the verbiage. Let's focus more on the practicality. All right, let's focus, because most of these questions about the language you will yourself be able to answer once we all do the hands-on. Okay, most of these questions can automatically be answered by you. Okay, so instead of getting lost in the theory, because theory of computing language is kind of difficult to get hang of without doing the practice. Okay, so I generally follow the thumb rule of first code and then learn. First code and then learn. All right. So let's just jump into it and start coding. All right. So do not be hesitant, because there is no other way to become a data scientist or analyst or a good developer. There's no other way than actually learning to code. Okay, learning to code is not is something every engineer, every scientist, every analyst need to learn. Okay, the coding need to be learned. This is my strong assumption, and the world is moving towards that. Okay, you should know coding, whether you do it or you don't do it. That's your choice. You have a gun, shoot it or not shoot it, that's your choice. So that's why I always say that we would do more hands-on, and we will try to build very simple program, so that we don't have any kind of mental blocks in coding. If you have done hands-on more, you will have less mental block in the trying out the programming. Okay, now let's try it out. Okay, so I'm going to open the console right away. Okay, although there is Eclipse, and there are these IDs which provide you an environment to type code. You can try those as well. Okay, but we will focus more on the getting on the runway, rather than building the castles. Okay, so although you can just basically download Scala Eclipse ID. Okay, so you can see download Scala ID for Eclipse, and you can use that Scala ID. Okay, if you want to use all right, how can I copy this? Okay, so you just search for Scala Eclipse ID and find it, and use that one, download it, and you can have the local installations. That is also a good way, but we will focus on our console, because here we will be using the same thing in case of Python. All right. Okay, so the easiest way to get up and running is typing Scala. All right, so everybody is able to start this. Wonderful, wonderful. Hank, wonderful. All right, so here the shortest code is not hello world, it's 2 plus 2. Okay, I'm going to take out my console in a separate window, so that we can jump back and forth quickly. All right, so who has written their first code? 2 plus 2 equals 4. Everybody? Great. All right. So we could define a variable just like this. All right. And we could say this. Is it easier? All right. This is called REPL. As we are typing code and pressing enter, it is evaluating. This is called REPL. REPL. What is REPL? Read. It is reading the instructions from us. Evaluate and print. Okay. So this is read, evaluate, and print loop. It is taking the command from us, doing something, giving us the result. Just like our console shell does. Okay. This shell where we type the command here. Okay. We type a command, it gives the result, and then it waits for another command. Similarly, Scala provides us a kind of command line or REPL where we can type the code as we go. All right, so everybody is able to define variables. So we just defined variable x equals to 2 and use that variable by adding something to it. Great. And we could also say x equals to x plus 2. Okay. And we could keep on doing that and it'll keep on increasing the value. Okay. This question is, do we have to use semicolon at the end of statement when writing Scala code? Not on the console here. And I think in the production also you don't need to put semicolon. So answer is no. Okay. Answer is no. Let me take a look at it. Okay. So, all right. Good. So that is the, all right. The other thing you could say, yes. Okay. So other thing you could try is executing a function called print hello world Scala. Okay, so you can see that. So semicolon is not, it's just optional. Okay, so you could try this. Okay, so we are saying here in this statement, every line is a statement that's getting executed. A statement is composed of complex structure. It is either it contains either the equal sign assignment or simply any execution. This is also a statement. Okay, so assignment or the statement, and the statement could be a function, it could be, so that's the whole statement itself is a whole language. All right, so function call, so when we're using from here, you don't need the semicolon as well, Hank. Okay, so is everybody able to do that? Please feel free to stop me if you are not. If I'm moving a little faster, please feel free to stop. Okay. All right. So that was the quickest way to get up and running. All right. So next is, so we have already done this. Now, let's say you want to run a program. You want to create a program, Scala script. Okay, let's try to create a Scala script that contains only this. Okay, first type nano this. Okay, let's create hello world.scala. Okay, let me also do it with you. Okay, let me exit here. Okay, and then I'm using println hello world. Okay, so I've created this. Okay, so after nano, press this. Okay, copy paste print hello world, Control X and press yes. Okay, what is the scalar script? All these statements, bunch of statements together form the script. So Christine, you have to type nano after coming out of Scala. Okay, so that is something I did quickly. I pressed Control. I pressed Control C, and I came out of Scala, and then I typed nano this. Okay, so I'm typing this command in the shell. This is called shell, where we type when you log in. The place where you land in is called shell. There are many kinds of shells. One is bash. That's the one we are using right now. Okay, so we are using bash shell, and on the bash we have started this. Okay, is everybody able to create this program? Now once you're done, oh, sorry Dheer, again, let me fix this window size. All right, this is better. Okay, so all I did was nano hello world.scala. You don't need to generally, I'm just, as a courtesy, I'm writing the surname for this file, but you don't really need in Unix the extension. Okay, you can have any extension. Yes, Hank, what kind of error are you facing? Are you able to edit and save this? Press Ctrl X to save it. Also, run this nano command. Run this nano command not inside Scala, but inside the console. Okay, now how do you run it? Yes, Dheer, Scala is case sensitive. If you try to do P here, almost every programming language, including Python, is case sensitive. Okay, you can see the moment I said capital, it started giving error. All right, so all of the programming languages are case sensitive. All right, so for me, the program is running fine. So we did not have to compile right now, but you can compile. I'll show you how to compile the code. Okay. So right now we are running Scala as a Scala script. Everybody is able to run. So all we did was we created hello world.scala using nano. If you are good at VI, you could use VI, and then inside that file we had put print hello world scala, and that's it. Hello world. And then we saved the file by pressing Ctrl X, and after that we executed scala hello world.scala. Good. Okay, anybody stuck? I would love to help. Awesome, awesome. So good, everybody, almost everybody is there. So anybody is stuck, I would love to see, because there could be something wrong in their environment. Okay, and I was amazed at the last time somebody got stuck. They actually created, something has happened in the environment such that Scala file got created. Scala file got created there. Okay, so they were facing a lot of problem, and they thought that they're doing something wrong, but it was mostly the environment. So feel free to shout out if you are stuck. Okay. Shashi is saying, what exactly happens when we execute a command, the command called Scala? It internally quickly do a just-in-time compilation and executes your script. Okay.
Okay, so here what we're trying to do is Scala hello world.scala. It is going to interpret each and every sentence written in this file and then execute individual sentence. That's correct, Dheer. Okay, so right now we have run Scala code using two ways. We have done hello world two ways. One, using the Scala console, okay, the REPL loop, the read evaluate print loop. And now let's try to do it using the compiled way. Okay, this is good for testing things out, but if you are in production, if you want to ship your code to the production, to the environment which is running for your users and users, there you might want to compile it and then send it. All right. Okay, let's try to compile the code now. All right. Now, when it comes to compilation, the process becomes a little bit more involved. All right. In case you want to just execute one statement from the command line as if it's a Unix command, you can also use this kind of format. Okay. So this is the third way of executing your program. All right. Okay. Every modern language provides this. Now, if you want to compile the code, the process is a little bit more involved. Let's try to do it. Okay, let's try to do it. This time, we are going to say nano hello world dot scala. All right, let's try to use this. Okay, we'll say nano hw dot scala. Okay, or you can actually say hello world, whatever I've said earlier. Okay, and now we can say scala c hello world dot. Okay, you could say scala c. Okay, one error found. All right. Now let's see if it works. Good. So we could say Java HW. All right, ls minus RT. You can see that it has, when we compiled the class, it has created these classes here. Just give me a second. I will show you. Okay, I will show you quickly. Not Java C, it'll be Scala. All right, good. Now let's move back. Okay, so before we jump ahead, there is some problem which Dheer is facing. It's saying that what's wrong with Scala this, because you have to put single quote here. Okay, otherwise Unix will try to interpret it. Okay, good. All right, next is let's do using nano and okay, let's create a file called capital hello world dot scala. This is how you write a code that needs to be compiled and shipped in the production. Okay. The extra baggage here is these two lines. object hello world extends app and this. A need to be, yeah, app is a superclass. That's correct, Hank. You got it right. The file name does not have to match this one. Okay, file name does not have to match. As I demonstrated earlier, the file I created was hw.scala. Okay, done. So using nano, using using nano hello world, you can create a new file called hello world.scala. H is capital, W is capital, so that it doesn't conflict with our previous script. Okay, and then save this into that file. Okay, I'll show you. When I say nano here, it is, when I say nano here, it is going to open this one, and then inside it I'm going to, okay, press Ctrl X. Yes, that's it. Okay, next is we say Scala C, Scala compiler, and then we use this. Okay, all right. So if you see your home directory, if you say ls-l, you will see these files: hello world.class, hello world.class, hello world, and so on. What is this? It's actually Java bytecode. When you compile Java code, then also you get these classes. Okay, when you say Java C, then also you get exactly same classes. Okay, so this is just to prove the point that Scala also compiles to Java bytecode. Next is to run it, you can say Scala hello world, and that's it. All right. That's correct, Bharni. That's correct. So I created earlier hw.scala and compiled. But the class name that got created was hello world. In Java, ideally the source file name and class name has to match. That's correct. Here, that's not the case. This is for compilation. Okay. If you are, so generally there is always this debate that keeps on going amongst the community that this programming language cannot need to be compiled, and there is a big loop of compilation. Okay, and therefore this programming language is bad and this programming language is good because it doesn't need to be compiled. So Scala stays on both sides of the both sides. It can be compiled, it can be used like an interpreter. Okay, all right. The I observed in the code that it needs to extend app. It is mandatory. Yes, it is mandatory. Okay, it is mandatory. Mitendra's point is that why two class files are created, uh, hello world.class and hello world $.class, because there would be some extra supporting classes. When we extended an app, there is a parent class that is also getting compiled here. So that is something part of Scala. It tries to provide you the additional needed functionality as part of the other classes. Okay. All right. So Japrika is saying I removed extending the class and run it. It shows error. Yes, because you need to extend it. Just like if you remember when you write Java applet code, you extend applet. Or you, when you are creating a thread system, you extend the thread and so on. So similarly here we are extending app. Okay, yeah, this hello world does not work with the does not work with using the standard Java one, because there are some path variables that need to be set, and that's what this Scala is setting up. Okay, that's what Scala is setting up. All right, I'm just trying to see what is this file. Okay. Mm-hmm. All right. So yeah. So there are a few more settings which Scala does while we run this way. Okay, before it internally executes Java virtual machine. Okay, that's why you can't run it directly using Java. If you try to run it using Java, it gives different kind of errors. Okay, there is no class definition found and so on. Okay, so that could be one of the cases. Let me see if I can run something else. All right, never mind. So basically there's some glue uh, variables that is being supplied by this Scala, and therefore it's not being run as Java. Okay, never mind. All right, dear. So now back to a little theory. There are two ways to define a variable: using var or using val. All right. And just like Pig Latin, it is optional to support to define the data type here while you are assigning things. Okay, so let's try this. Let's go back to my terminal and launch Scala. This will be the easiest way to try it out. Okay, either you could say var int x equals to 10, okay, or you could say well y. Okay, defining the data type is very much optional. Okay, so you could try, all of you could try this. Okay, there are two things, val and var. Now the problem with val is that if you try to reassign the variable, it gives an error. You see that? We defined y equals to 10 and we are assigning 10 again to y. It gives you an error. While we have defined x as var, and we could redefine this. Okay, so the vals are immutable, correct? Is similar to constant. That's correct, the and Mrityunjay. So well, if you say something well, which means it is immutable. Okay, once you have defined it that way, you won't be able to change it later on. It protects you from by mistake overriding things. It's actually quite useful syntax. At a lot of places, in past when I was coding, what happens is that I define a variable and then I by mistake overridden it by some other value. Okay, so it is, if you have to define some constant, you can say, well, if you are don't want constant, you keep on making modifications, then you could use var. Okay, and if you want to define a data type, you could either say x colon int, or you could just assign things. Okay, all right. All right, so I'll show you some more things.
let me see if you can define. No, you can't define it that way. All right. Next is that we could, a question from Deer is that, is there a concept of primitive and object data types in? So everything is an object. There is no differentiation between primitive and object. Everything is an object. And okay, so there are two things, objects and functions. Function itself is another object. Okay, so just like JavaScript or Python, they have tried to keep the functional kind of definition. Okay, so they have taken best of all kinds of programming language and used it. If you want to define something as a string, you put it in double quotes and define it like this. Okay, and also with val you could redefine things just like here. All right, while where y, okay, let me see. So you can redefine data types using where or val. All right, you could define a bigger structure, say map. You remember map? Map is like a hash map, like a big dictionary, which has key and the value. And this key is a string and the value is a list. Okay, let's see what happens. So this is a complex object. Okay, so this is a way of saying this is the key and we are assigning a list of values to it. Okay, this is a shorthand for providing key and value. Okay, so it means the key and value. All right, so we are saying, if you take a look at it, there is this map, okay, and that contains, I think I can access it like this. No, let me see if I can do this. Yes, okay, so we have defined this map that contains the key as ABC. If I say map.get and provide a key, it gives us a list. All right. Okay. Some means it's an object. Okay. It's an object. Okay. So this is what it is. So okay. So this is explicit and this is implicit. Okay, so let me correct it. Actually, this is wrong. All right. So this is implicit and explicit data types. Okay, so everybody with me so far? All right. So let's try to calculate the interest based on what we have learned so far. Okay. So to define a function, you generally write in this way. Okay. This is the way you define a function. All right. This is the way you define a function. So you first say def, then the name of the function, and then the first argument, the data type,
then second argument and its data type. Here data type is mandatory, and third argument and its data type, and then the return data type. So this function called interest takes p, r, and t, double, and integer as argument, and returns a double value. Correct. It looks like a Python function with minor tweaks. Okay. If your function is multiple lines, you could also define it in this way. You could say return this. So either you could define this way or you could define this way. Okay. And you can execute it in a very simple fashion. You could basically say things like this. Okay. Yes. So this question is, can we pass null parameters to function? We will talk about it in a while. Of course, you can do. All right. There is the method of something called default value in argument, just like any other language. Okay. So Bernie's question is, what is this res2 or res3? So when we are running a function, it's defining temporarily some variable, and that's what is being printed. Internally, it's actually defining a temporary variable and printing its value. That's what it's showing here. Okay. Although that variable may not be visible here. Oh, it's visible. Interesting. So you can actually use res3 or res2. Nice. Thank you, Bernie, for that question. So I'm also relatively new. I'm not a professional at it. Okay. So yeah. Also, one more important thing is that if you just provide, if you just provide a single statement, something of this sort, then you don't need to put return value. Okay. By default, whatever is the value after evaluating the last statements in the curly brackets, that will be considered the return value. Okay. Okay. So who all are able to do the interest? Okay. Good. Good. Wonderful. Wonderful. So you are able to write your first function for computing the interest. All right. Let's take a break for 10 minutes and we'll be back by, okay, break for 10 minutes, back by 9:47 p.m. IST. All right. Thank you, Christine. And 11:17 a.m. CST.
Hi everyone, can we start now? All right. Okay, so is everybody able to compute the interest? Wonderful, wonderful. Okay, all right. So now let's try to move to the next level. Let's try to compute something called tax. Okay, all right. The way you compute tax is that, so here are the rules for taxation that, all right, I'll just, I think you must have got a copy of this one. I will also give you a copy, okay? So I'll just say, click, get a shareable link. Okay, now you can copy this. So you can open the slides for everyone, okay? Whatever I see on the screen, you will also see the same thing. If I modify it, you will also modify it, okay? So I've shared the slides for you. You can just open those, all right? Now, where is my, all right, good. So here we go. And all right. So everybody able to open the presentation so that we can share the same thing. All right. Now let's try to compute the taxation. The problem statement is for the interest for INR, I'm saying just rupees for time being. Okay. So for 3 lakh, which is 300,000 INR, there is zero tax. For 400,000 up to from 300,000 plus up to 400,000, it's 10%, and so on. Okay. So your the problem statement is given a certain amount, okay, given the income, you have to tell the taxation. For example, if somebody's income is 300,000, the tax is zero because it is in this range. If it is 400,000, the tax is zero on first 300,000, and then for 100,000 it is 10,000 INR. Okay. For this one, there are 50,000 on 50,000 rupees, you get 20% tax, and for 100,000, you get 10%, and for rest of it, you get zero. Okay, so for 50,000 rupees, you get 20%. That means 50 into 20, that is 50 into 20, and that comes to 10,000. 10,000 plus 10,000 is 20,000. Okay, so are the rules clear to everyone? Okay. All right. So those who are not comfortable with the the if else condition, if else condition is very simple. Okay, you can say if this greater than that, and so on. Okay. So here I'm saying the income is something which I'm passing as the argument, which is which is a double data type. Double is a decimal number, and I'm returning double, which is again a decimal number.
Here I'm saying where income. I'm defining a local variable called income and passing the argument there. Okay. There is only if in the conditional statement. That's right. Somebody was unmuted. Okay, never mind. So, okay. All right. So this is what I have written. Okay. Can you make it better? Anybody? So first, let's try to create this. And is it clear? Is the logic clear to you? So here we are saying if we are going top down, if greater than this, we are setting the next level and so on. Okay, because for below 5 lakh, rest of the computation will apply. A question from Mrityunjay: do we have switch statement in Scala? They have case statement in Scala, yes, but we are not going to use that one for now. Okay. I think they have a switch statement, but we are not going to use that one, right? Question from Babu is, if income is greater than this, then all if statement will be satisfied. That's correct. So first this will be applied and then income will be reduced, and then, okay, income will be reduced. Then here, since 55 lakh, let's say there is 6 lakh, okay, for 10,000, this is the tax that's computed. Okay, now for remaining 5 lakh, this will apply, and then the tax will be added. Okay, and then the income will be set as 4 lakh, and then 4 lakh is again, this will be applied. So that's the reasoning behind not keeping else. I'm letting it fall through everyone. We can use else, definitely. If you use else here, then for the remaining amount for 5 lakh, you have to anyway apply remaining slabs. That's why I have not used else, if else. Because so anything which is above this amount, you have to apply this slab, then this slab, then this slab. That's why I'm just using, letting it fall through all the if conditions. Not clear? Is everybody able to run this? Let me also run this. Okay, compute tax. Let's see. Are you trying to come? Okay, are you trying to do it from the, you know, from the file? Okay, let me also try to do it from the file. I've tried to run it from here. and it runs perfectly fine. So let's see, 3 lakh 0, 4 lakh should be 10,000, 4 lakh 50,000 should be 20,000. And what were the other test case? These are called test cases. Okay, these are called test cases. And before starting to code, we should generally build the test cases. Okay, is it working for all from here? I'll try to do it from the file later on. Okay, Swan. All right, so that's how we do the compute taxes. All right, any questions at this point? Any other questions? Let me take a look at why. Okay, so Hank is facing this problem. The error not found value income tax equals this. So how are you running it? Using the console? Okay. So did you define this one? Did you define this one? Compute taxes? And you also put this one in place? Okay. Try copy pasting again. I think it should work this time. Okay. Sure. I can definitely copy paste it. Sorry. This is not correct. Just a second. Okay, so let me go back. All right. So yes. Now I've copy pasted again. You can just copy and paste it on the console from the beginning till end. Shashi is saying, how do we pass the argument when running from a file? Okay, so yes. So there, while you are extending, you can define the argument to the function main. Here you can see that. You can actually, let me see how we can. There is a main method way of doing things. You can define a main method here, and then you can define arguments to it and use this. Okay, you can pass arguments there in the main method. I'll show you later. All right. So I'm very, trying to be a little more concise in our approach, because the programming language itself, learning the whole language will take us maybe 10 classes. That's why I'm trying to be a little more concise in the approach. Okay, and I think this slide should have moved a little up. Okay, done. Everybody with me? So we are trying to define functions right now. And before theory, we have done it already. So we can either define functions in a very simple manner without curly brackets at all. You can see there are no curly brackets. Or we can put curly brackets. We can call a function like this. Okay. And we can pass different arguments. Okay. All right. And you can also say that my function does not return anything by not providing a return data type. Okay, so everybody is able to execute the first calculate tax function. Hank, did it work for you? Did the copy paste work? Good, great, wonderful. Everyone, is anybody who needs a little help at this point? Okay, feel free to let me know. Okay, because these are starting phases of any new language. So the initial inertia could be a little more higher than expected. Okay, once you are up and running, things will be far more smoother and you will have more confidence in trying out new things. And also learning by searching online will become easier once you have tried the basics. Okay, I mean, learning 90% language is actually very easy. It just only first 10% takes the maximum amount of effort. Okay, that is the truth of the computing. All right. Now let's try to do a little bit simplification. Okay, so I've tried to do a little bit more modelization. I've tried to define a function called slab tax. Okay, in which I pass income, the lower slab, the slab, and the rate. Okay, and the rate, so that given a slab, it can compute, do the computation. So basically, each of these blocks, I have made it into a function so that this computation can be done inside a function. Okay, that's what I have defined here. And then I'm calling that function again and again. First on this amount, then on this amount, then on this amount. Okay, basically this block of logic I have made a function. Okay, and also there is one more thing that you must notice, that there is, other than an array, so you can define an uh, array in scalar just like any other value. Okay, you could define array like this. Okay, so I'll say where x, just a second, just a second. I'm also relatively new. Okay, so we could define a list of things this way. Okay, so this is the array. Okay, so you'll have to say x dot get. All right, so you can see this is the way you can call. So that we defined an array like this. Okay, or you can also define something called a tuple, This is a tuple, okay? And tuple can be called just like an array. Not like this. How do you call this tuple? You call it, how did I use it here? Using underscore, okay? $1 underscore G, 1, 2, and 3. Okay, let me uh, rephrase what I have been trying to explain, okay, from the beginning. So there is something called a list. You can define a list like this, which is basically an array, okay? This is an array, okay? And then, yes, that should also be possible, Deer. Yes, that's correct. Thank you, Deer. Yes. So you can either define a list of values like this or like this. Not like this, sorry. This is not a list. This is tuple. Okay. So I will, yeah, that is a little bit of a problem. Okay, let me explain what does it mean by tuple. Okay, let me explain what does it mean by tuple. So there are two data types which look very much similar. Okay, and in most of these newer languages and most of the functional languages, there is array, okay, and there is tuple. Both look alike. Okay, tuple is just immutable. Okay, tuple is immutable, meaning you can't insert elements to a tuple, while array or list can be modified. Array or list is the same thing. Okay, array or list is the same thing. So tuple, you can always say tuple is immutable list of things, meaning you can only create it, you cannot modify it, you cannot say append a value to it. All you can do is access the elements of it. Okay, and tuple can hold different type of values. Yes, list can hold only simple single type of elements. Okay, so that's it. All right, now going back, so this is our list, and if this is our tuple, this is how you define tuple, and you can see that the way you access tuple is using this kind of annotation. Okay, while if you're defining a array or a list, you will have to use x, y, 0. You can see that, and so on. All right. So this is the kind of notation you use in case of tuple to access. And here, okay, let me try to describe it a little bit more. All right. Okay. So clear, is everybody clear about the difference between the list and tuple? Great, great. Yes, tuple starts at 1. Also in tuple, you can give names to the placeholder. You can say, this is my first, this is second, this is third, and so on. We will discuss those things in detail. Okay. Okay. So yes, this is very much possible. Thank you, Shashi. Deborah's question is, how is array or list different? Okay, so array and list I think are same in Scala. All right, array and list are same thing in Scala, and we will see how they differ. All right, most likely list could hold. No, actually, array and list are same thing probably. You'll have to take a look at it. Exactly what does it mean? So okay, and a question from Hank: how to define a value for a dict? Okay, so a value for dict is, so when you define a dict is nothing but a map. Okay, so you define a map like this. Okay, so it says that this map contains nothing, so you can say add ABC and put, let's say, some value to it. There should be a way to do it. I think put is not a member. I'll have to see how exactly do we do that. Okay, it says, ouch. You know what has happened? I should have defined the data type here. Okay, so let me just define data type in a very simple way by setting some value. Now I can add more values to it. What happened to this? Okay, it is a string. That's okay. Let me try to do this. Okay, I'll have to take a look at the various libraries. Okay, no worries. So we have X, and generally we should be able to add values to it. Okay, we'll take a look at it as and when required. We'll just do a search and do that. Okay, parallelly we can open a manual. Okay, so all right, I'm just taking a look at the map. I think this will make it more clear. Okay, this is working fine. Okay, this is working fine. So I'm defining A equals some map. So I'm saying A is a map of char and integer. Okay, the key is a character and the value is an integer. Okay, then then what we do is we say, so we are using the reassignment to the well. That's okay. Okay, so yes, so this works just that. Uh, all right, so I'm saying that add this key and value to the hash map. Okay, so you can see this. All right, so if I say A, it shows us the map like this. Also, please note that we could define our map in this manner as well. Let's say I say where B colon map. Okay, I just have to wrap it in the single quotes. Okay, so we could also define something in this way. All right, so all right, this seems to work fine, and this is working fine. All right, so that's how you interact with the map. Okay, so there is another way of computing text. Here you can try it out. All right. Oh, I have shared only with Swan. I think I should be sharing it with everyone. Okay, good. All right, good. Now, a function can call another function. Okay, a function can call another function in this following way. So how many of you know what does it mean by factorial? Factorial means multiplying a number to all the numbers below it. Okay, for example, factorial of 10, so factorial of 3 is equal to 3 into 2 into 1. All right, so you can basically say that factorial of 3 is equal to 3 into factorial of 2. Is that correct? Similarly, we could say factorial of 4 is equal to 4 into factorial of 3. Everybody with me so far? Correct. So you can basically say things like this. If x is 1 or 0, return 1, else return this. So if you put curly brackets, you can write the return statement. Otherwise, you can actually write in a single statement. Okay, you can actually write in a single statement. Yes. So let me try to execute it if it works. So we'll say factorial 4. Okay, factorial 4 is 24, factorial 3 is 6, and factorial 30 is a huge number, and factorial 300 is so huge that it can't fit into the integer, so it has given us 0. Okay, so 31 is something I think is the limit for this. Okay, you can see that. So it has overflown the integer. Okay, never mind. So basically, we have defined a factorial which is a recursive function. All right, you can try it out and it should work fine. Done? Good. Let's move ahead. So although we have talked about list already, but so a list is basically list of things, list of numbers, and list has got a data type, which means all the values in a list have to be the same data type. List, if you have to go over an element of the, if you want to execute a function on every element of the list, you can use for each method. Okay, so here we are saying that for each element of this list, execute print. Okay, execute println, or you can actually simply say this. So it's a very shorthand for iterating over the elements. Okay, instead of you writing the for each loop, you are letting the system iterate over the list and then calling your method against every element. Is it easier for all of us? Okay, so let's try to do it. So we have list, I'll just call it list, and here I've just defined the list. So on this list method, I could say for each, okay, for each, and okay, I could just say here print, and here we could also say +1, just for the demonstration of that this particular part is executed on every element. Okay, or let me just say divided by 2. Okay, so our logic is getting executed on every method. Similar is the case with map. Map essentially generates a new list with the new values. Okay, so here we are saying that for every value of this list, execute our map function. And what does our map function do? For every element, it increases by 2. So the new list that it generates will be 2 more than this. So you can see that the map and reduce that we studied earlier in case of Hadoop map reduce, those are actually those actually came from the functional languages like Scala, Python, and Perl or Lisp. Okay, so map method, this is the place from where the map and reduced keywords have been picked up by Google's MapReduce, and from there. So this question is, what is the difference between this and this? Honestly, I don't know. I'll have to look into it. All right. I'm also quite, you know, a beginner in the case of this. Okay. So here it is basically calling a function. So this is very clear here. This is basically calling a function, while single one was for defining the key and value for the map. That was for the map. This one is for calling a function saying this is the argument and this is the statement. Okay, so that is, I think that's the difference between okay. So a question from Hank is, it can only add, multiply, divide one by one list array. So not only that, you could do a lot of things here. Here you could actually run your own function. You could say calculate tax here. Okay, calculate tax here, and put some value. Okay, or you could say factorial, for example. All right, so you could actually say factorial x. See that? So this was the list. If this list was made up of, say, more elements, okay, let's say 5, 7, 8, 11. All right, we are saying where here, and then we are calling factorial on every element. So you can see that it has computed the factorial of all the values. Okay, clear to everyone? So, all right. So those who have, the way we have learned computing so far is that iteration is done by us. We write the for loop. Okay, we could also do uh, iteration saying while x in do while kind of loops. But the difference between the looping and map function is that we, in case of map function, we leave the control to the system. Okay, we let the system decide how to iterate. We only define the translation. We do not define the iteration, whether the system wants to use the multiple threads or multiple processes, or a system wants to start from the end or the beginning. In case of map, we don't care about that part. All we care about is the logic of translation. Okay, so that is the big difference between the two. In case you write your own for loop where you're going from left to right, picking it up, those kind of logics are difficult to distribute. Meaning, if today you have multi-core systems, if you have multi-core in your processor, that for loop cannot be distributed to multi-core. But map function could be executed parallelly on multi-cores. Okay, as we go with Spark, we will become more familiar with map way of doing things. Okay, yes, that's correct, Shashi. So that we will become more familiar to the parallel way of programming. Okay, this functional way of programming where we do not try to intervene in the iteration. We do not try to define how to iterate. Instead, we focus on translation. Like the way when we write our SQL query, we don't care whether the system is filtering from top to bottom, or is it doing it parallelly on many machines, or is it doing it using multiple threads. We don't care about that part. All we care about is that whether our SQL query, whether the elements are being filtered or not. The logic of filtering is ours. All right. So Swan's question is, how much level of Scala we should know for understanding Spark? Very basic level of um, Scala is needed, but it would depend on the kind of projects you use. Okay, the kind of projects you work on. Okay, maybe you need more data structures, you need um, more understanding of libraries, and so on. So it is based on your usage. Okay, very good. So that one was all right. Now, similar to map, you have filter and reduce. You can see that. We will talk about reduce a little while later. Okay, while we discuss our what do you say, uh, our Spark in detail. All right. So filter is basically filtering every element on certain criteria. Okay, for example, we have this list. Okay, we have this list. It has got these many values. Let's say all we are looking for those values which are even. So what we'll do is we will define filter on this. We'll say filter x, and then we define the function that x percentage 2 equal, and I think that should do. Okay, okay. So x percentage, in case the if you divide every element by 2 and the remainder is 0, okay, that means this condition is going to be true. So in case of filter, your statement or your function that you're passing should be should be should be the function that you're passing here should be returning true or false. Yes. Okay. So you basically define true like this and false like this. Okay. So you can say where flag my flag equals false. Okay. You can see that. All right. So that way you define the true and false. Now you can see here that we have, okay, out of these many values, only 2 and 8 are the ones that are even, and only those have been filtered. Is it clear to everyone? Yes? Okay, wonderful. Same thing you could also do in this way. All right. So you could actually say the same thing by using underscore. Underscore by default means each element. Okay. Now there is something called reduce. All right. All right. What does it mean by reduce? Okay, I'll explain. This is something which we have not discussed yet. So did we discuss idempotent? No, did we discuss the functions which are applied again and again and still the result is same? Commutative and associative. Yes. Or I think we can leave this till the point which when we discuss in Spark. I'll go into the details at later point of time. Okay. Let's skip the reduce part. Okay. All right. A question from Hank is that any help underscore doc is available. Generally, you can take a look at the online documentation. I'm not sure how do you see the documentation on the console. All right. So that's how you define the list. Now, with respect to the object-oriented programming, in Scala, you can define the classes as if you are defining in Java, just like this. And by default, while we are defining the class, you can pass on the arguments which are required in the constructor. Okay. So we are saying that this is my class and this is the constructor, this is another constructor. And while we are going to initialize this class, we can call this way. Okay, so we can create an object of this one. Yes, this is very much like a class. So just like Java, we can create our custom data type or custom object. So here we are saying person is a custom data type, and while creating person, we can pass on few parameters to it, and these parameters will be saved in these two variables, and this will be printed. Okay. And later on, if you want to access the subcomponents of this person called age and name, we can access those. Yes, these are parameterized constructor. All right. So Hank's question is inheritance and polymorphism, overloading constructor, everything, everything is there in Scala. Okay. You have interfaces which you can extend, you have classes that you can extend further, and so on. Okay, you can also overload functions, you can define the values for them, and so on. All right. A question from Hank is that, sorry, Hari, is that if we have other definition like calculate text, do we need to put it in constructor too? So yes. Not really. In case of calculate text, okay, if we have here, you mean if we have other definition like calculate text, do we need to put in constructor too? Mm, in case you're creating a class out of calculate text, then you will have to use the you can create the constructor. Yes, this looks more like Java and Python combined. Okay. All right. Now going ahead with a few more things. Yes, a question from Dheer. What does it mean by object in Java, in Scala? Object is just like your Java object, which is not similar to JavaScript. Okay, which is not similar to JavaScript because in case of JavaScript there is no concept of class. Okay, everything is an object. Okay, now yes, it is very much similar to Java. The class and objects are very much similar to Java, and just that it is a little simplified syntax and faster than Java. Scala is faster than the usual Java classes. This question is, how can we define constructor in Java, in Scala? This is how you define the constructor. Okay, by default. Yes, attributes, these variables are kind of public by default. You can change their accessibility. All right. If you have multiple constructor, how can you define? The idea is setting the default value of the argument instead of defining multiple constructors. Setting up default values instead of defining multiple constructors. All right. So you can pass in and set the default value for the constructor so that those values are assumed by default. All right. Uh, okay. Next is yes. The other things which I would like to move ahead. Okay. So, all right. We will discuss in more detail as and when we require. Okay. So allow me to stay brief a bit, and we will go into more details whenever it is required, and we will more be focused on our end objective. All right. Now, other than the basic data types, like we talked about int, char, string, and we also talked about double. Other than those basic data types, there are more objects available in the Scala collection. Okay, So in case you have to do a lot of computing, you may find these data structures very useful. Okay. And exactly like Java, you have basic data type called traversable, meaning list is a traversable, something that you can traverse in. And then there are iterable, then sequence, and set and map. So sequence extends iterable, set extends iterable, map extends iterable, and indexed sequence, linear sequence extends the sequence. Set is, there are many kinds of set, and two of the examples are sorted set and bit set. Okay. And map, there are many different kind of maps. One of them is sorted map, meaning keys are ordered in this map. Okay. Yes, Scala supports multi-threading, and just like Java. All right. Hank was able to answer your question, and Jayaprakash. All right. So other than these data types, these data structures provided to you by Scala, okay, there are, you can use the other data structures. For example, Java utils data structures, which are coming from Java. Then Apache Commons collection. There are something which are done by open source world in FastUtil, Google Collections, Trove, and there are quite a few existing data structures that you can use inside Scala. Okay, so you get all the richness of Java libraries along with the brevity, along with the succinct code of Scala. All right. So we have talked about map and we have talked about list. All right. So, all right, that's pretty much for today. Okay, Jayaprakash's question is, how can we use Java utils class in Scala? Okay, so you can actually import that. I'll show you how to import during the class. Okay, we will use the Java libraries during the class. We can simply import java.util, okay, in our code. So that's yeah, that's pretty much about Scala. I would like to move to Spark. Is that good? All right. We'll spend more time on understanding Spark and trying to using Scala. Okay. All right. So going back a bit. Okay. So before we get into theory, let me just get you started on the shell of Spark. So Spark also provides a shell. Okay. The way, exactly the way we have just now done Scala programming, you can actually launch Spark in the same way. So instead of writing the code, compiling it, then handing over to the MapReduce and then waiting for the results, in case of Spark, you can get the work done instantaneously, and that's what separates Spark from MapReduce. Okay. Okay. So Swan's question is how to run program from a file. So we have been able to run a program from a file, right? Using Scala C and then using Scala. Is that what you mean? Okay. Hank's question is, so Spark, where is it located in Hadoop component layout and architecture? I'll explain to you, don't worry. All right, I'll explain to you while we discuss about Spark in a little bit detail. So the way you launch Spark shell is this. Okay, so this is nothing but Scala shell, which is connected to Spark. Okay, just the way Pig or Hive provide us the shell, Spark provides us the shell where you don't need to, Spark did not create its own programming language. Instead, it's provided Scala or Python programming languages. Therefore, you can see that Scala has been started. Okay, so this command prompt is Scala command prompt, just that there are additional libraries, additional handles with which we will be talking to Spark. So using Scala as a programming language, we will be talking to Spark. Okay, Spark is a component running on the cluster, and right now there is an object called SC. Here you can see that SC is connected to the Spark. Okay, SC is an object created for you so that you can interact with Spark via this Scala shell. So when we said Spark shell, it essentially initialized the connection to Spark, okay, created an object called SC, and gave you the Scala shell containing those objects. All right, so this is clear to everyone. So yeah, so this is our gateway. This Spark shell is a gateway to Spark. Okay, there is an object called SC, which is a handle to Spark, and using SC we will be interacting with the Spark via Scala console. Okay, so this SC object is initialized internally via Spark shell. Okay, when we say Spark dash shell, it will first create a connection to Spark, create an object called SC, which is just like the way you interact with a file, you create a handle. In the same way, we interact with Spark using SC objects via Scala programming language. Okay, so you get Scala as a programming language as well as Scala's console. Okay, so in case you are not, if you are coming from Python background, so you can say PySpark. Okay, now it again starts, it again initializes the connectivity to Spark. Okay, and creates an object which is a gateway to Spark, and now you can talk to Spark using Python. Sounds cool? So if you're coming from Python background, if you're coming from Scala background, if you're coming from Java background, Spark welcomes all. Okay, and and using either of the language, you can interact with the Spark. Hari's question is that the general practice to work with Spark? So I'll tell you something. So in today's world, when we code, whether JavaScript, Python, or Scala, or anything, any new language, say R or any other programming language, in most of the cases, you are given a REPL, read, evaluate, and print loop, meaning the console, or meaning the shell, meaning the interactive interface. You're provided this interactive interface on which you can write the code, okay, and get the instantaneous results. This improves your overall productivity, improves your enthusiasm to interact with the language, and then you keep on preparing your code, which you basically call a program. Okay, while interacting via console, you keep on trying things and preparing your program, and then you can submit that program. Okay, so the general strategy with even with the Spark is that you try everything via console. If you are and if you want to ship it, then you gather all the things as a script and then submit it for the production. Okay, so that's how you generally code these days with the newer tools. Okay, those days where we used to, you know, try to do everything in a single shot, compile and submit, that's those days are gone. Okay, because that way of programming generally is not that interesting. Okay, getting an instantaneous getting an instantaneous feedback is what is most important to solve your problems. Because if you have to if your execution loop is very long, there is a subconscious inertia of trying out all kinds of things. Okay, and in computing, if you can't try out new things quickly, you build up this subconscious inertia, and your code might have more bugs than expected. All right, so you, while coding, you keep the console open, you keep on trying and then building your code, and then you execute it as a single program. All right, all right, so I will move ahead. Okay, all right. I think we have already discussed this part, if you remember from the first session. Okay, so there were shortcomings of MapReduce, that every MapReduce cycle reads from and writes to HDFS, and that was heavily reduced by Spark. Okay, so this is the general architecture of the Spark, whereby there is Spark core. Okay, and Spark core runs on top of Yarn, EC2, standalone, or Apache Mesos. Okay, so okay, so the most important part of the Spark is the core of Spark. This core of Spark contains all the logic. It contains all the logic that is required for distribution. Okay, it contains the main logic needed for doing the distributed computing, and there are the basic primitives that are done as part of Spark core. All right, now this Spark core can run on any of the existing resource managers. What is resource manager? Resource manager is something that executes a program in distributed fashion, which provides your which provides you the details about which resources are busy, which resources are available. And, and as we described earlier in case of Yarn, we could also tell the resource manager to run our program with certain constraints, such as executing your program near the data. All right. Similar is the case with other resource managers such as Amazon EC2 and Mesos. Okay. So Apache Mesos is also a competitor to, to Yarn. And in case of Amazon EC2, it is a hosted one provided by Amazon. Now, the standalone part. Standalone is for the situations where you are not having your existing cluster. If you do not have your existing cluster, you you would prefer to use the standalone way. Okay. So in case you do not have your own resource manager such as Yarn, or meaning you don't have an existing Hadoop cluster, in those cases, for those kind of scenarios, Spark comes up with a built-in resource manager. Okay, that's called standalone. So the way we talked about Zookeeper, that we install Zookeeper everywhere, um, and then Zookeepers are informed about all the instances, then Zookeepers talk to each other, and so on. Exactly in the same way, Spark's standalone way, Spark standalone resource manager is installed. So you install Spark on all the machines, and then inform all the instances about all other machines, and then turn on the Spark. That way, the Spark instances will start communicating with each other, and one of them you can mark as master. We will, the way we have been talking about master and slave. So similar way, standalone also provides you. Okay, that discussion we will do it in detail later. Now, Spark Core is built with this strength of reading data from all kinds of places. Okay, you remember our MapReduce discussion where we talked about that. We talked about the part where our mapper logic is executed near the data. Correct. So Spark Core comes with this magic whereby it executes your logic nearer to the data, whether it's HDFS, HBase, Hive, Tachyon, or Cassandra. Okay, even in Cassandra, the Spark can execute logic nearer to the data. That is the magic of Spark. Spark has done a lot of work in making execution of the logic possible closer to the data. Okay, so all of these kind of data sources, it can not only read but execute logic closer to the data. And that is the very important part about Spark. Okay, now you can talk to the Spark by the way of various libraries. Okay, you can talk to Spark using R, SQL, Java, Python, Scala. Okay, as well as Spark provides you these nice libraries such as streaming, MLlib, GraphX. MLlib is a very rich machine learning library. The reason why I have skipped Mahat for our discussion is because this MLlib is very powerful. So it has basically, you know, overshadowed every other distributed library. Okay, we call it machine learning at scale. What does it mean? Machine learning on a smaller data is possible using tools like NumPy, SciPy, and R. But when it comes to bigger data, using many machines, it doesn't make sense to use R or any other tool, because R can't handle data beyond what can fit into the memory. In those cases, MLlib is your only solution, because MLlib provides you this immense power. And as of today, when I compared all the available libraries for machine learning at scale, distributed machine learning, nothing comes closer to MLlib. Okay, So there was some other libraries before Spark came along, other proprietary libraries. But now MLlib is not only best in case of open source, but also it is better than the proprietary ones even today. So NoSQL is not there, Hank, in Spark, because Spark is more of a computational engine. Spark does not provide storage. Spark does not provide its own storage. Instead, it relies on third party such as HDFS, Tachyon, HBase, Hive. Okay, GraphX is one library for doing the computation on graph, and streaming is one library which provides you the streaming abilities. Okay, all right. So Spark's architecture, it looks like this. Okay, so at the core, okay, what happened to these? Okay, so at the core of Spark, the most important part is that it contains something called RDD, Resilient Distributed Dataset. Okay, it contains resilient distributed dataset. And okay, so a question from Hank is, can Oracle be interfaced with Spark like ETL function? Yes. All right, so I think we are beyond our time. So we will start with interacting with Spark. We'll do the ETL. We'll run through a couple of examples when dealing with Spark. Also, I would here in the second session, we will, okay, we will talk about RDD, we'll talk about architecture, we'll talk about the different modes in which Spark runs, and then we will talk about, we will do the basics using core, and then we'll use these libraries, Spark SQL and others, so that we all are on the same page. Okay, these are the discussion that we are having for next 2 to 3 sessions. It's a very important part of this course, so do not miss this part. If you, in case you miss, I'll make sure that I immediately upload the video so that you can finish it before the next session. Okay, all right. Okay, so in case you miss and you are not able to cope up with certain part, I am open to do a one-on-one during the weekend, during the weekdays. So feel free to reach out to me. I would love to do the one-on-one in case you are stuck. All right, great. So see you next week. Hari's question is, can you tell the command to launch Spark from Scala? It's a Spark shell, Spark dash shell. Okay, Spark dash shell. Bye bye. Have a good day and a good week ahead. I look forward to the class next week. All right. Bye. Have a good day.